Hi, welcome to this video. Today's video we are going to evaluate this integral. We have a product of natural log x and natural log 1 minus x dx, the bound from 0 to 1. If you would like to take a try, just pause the video. When you worry, come back to see how to solve this problem. Let's begin. Usually when you see the product of two functions, you may use the integral by part, but in this case we see both functions have natural log. So if you take the by part here, it takes you to a long expression when you're using by part, which is more challenging to solve it. So the idea of to use the by part, integral by part, it will not work. So we will use another way if possible. Now if you take a look here inside of the natural log, we see 1 minus x. Usually we see this expression, usually use the geometric series. So we will put this one as a form of sum of x and equal 1 minus x from 0 infinity and from 0 to infinity. So that's what it is here. This equal xn equal 1 minus x power of n and the power of n plus 1, but this one it will go to the 0. This is a condition, xn plus 1 here, always x inferior than 1, so this one go to 0 when n approach infinity. Okay, so our expression is one. In another words, like natural log 1 minus x prime of natural log 1 minus x equal 1 minus 1 over 1 minus x. We can change it again to the original function. We will integrate this one. Our integral become now natural log of 1 minus x equal from 0 to x dy 1 over y. This is one exactly this one equal this one. If you integrate this one equal from 0 x, this is geometric series y from n equal 0 to infinity dy. This one we can bring this some sign outside of integral. We will become now, we switch 0x y and dy. So the integral, let's call it j integral, let's call it j integral, or gn integral, for example, equal natural log 1 minus x, for example, equal from 0 to y, dy 1 minus y equal this one, 0x infinity. What is this? This is, if you will integrate this one, it become 1 over n plus 1 y n plus 1. You can put it right away. You can put it like this: 1 over n plus 1 y n plus 1 from 0 x. Okay, this one equal equal 1 over n plus 1 x n plus 1 minus 0. So this one will be this one here. As you see here, this one now we will plug in original integral. We will see what happened here. So our integral I equal minus 0, 1 natural log x. Put the negative sign outside of integral, so it becomes this one now, sum of x n plus 1 over n plus 1. Okay, the whole thing dx, put dx is cover whole integral. So we can bring this one outside because it is considered as a constant. Okay, always from 0 to 1 or integral. So xn plus 1 dx always from 0 and from 0 to infinity. Don't forget we have the natural log inside, so you can put the natural log first. Natural log first. In this expression we can use it by parts, this one. So you can put I prime equal, for example, x power n plus 1 v equal natural log x. So our I integral can put the minus sign outside. You can put this one as this one. You can put g1. We can put g2 as an integral. We're gonna bring ones. You can calculate separately, then we plug in at the end. Okay. So from 0 to 1 natural log x xn plus 1 dx. We're gonna apply by parts here. So our integral will become, this is as a prime. You're gonna put in the original function and put 1 over n plus 2 xn plus 2 log x from 0 to 1 minus 1 over n plus 2 xn plus 2 from 0 to 1. This one, if we differentiate this one, become 1 over x 1, so that's mean dx over x. Be careful calculating this one. You can plug 1 is okay, you'll be 0, but this one, be careful when you plug 0. You cannot plug it right away because this is it's indefinite form. So this one we will use the limit of this one. So the limit, so that's mean 1 you plug, this is 0 because you plug in 1, 0 minus limit x natural log x 0 plus multiply by x square n plus 1. Okay, minus 1 over n plus 2 from 0 to 1. X become this one. This one, if you're gonna cancel out x here, become x square n plus 1. Okay, minus x n plus 1 dx. This one is 0. Okay, now this only this one 1 over n plus 2 become 1 over n plus 2 x n plus 2 from 0 to 1 equal what? Equal this expression equal 1 minus negative sign 1 minus n plus 2 square. Okay, now we will bring this one to here. Okay, because we're calculating this one now. So our I integral become minus with a minus, negative sign with a negative sign, it become plus. So our integral become sum of 1 over n plus 1 multiplied by n plus 2 square. Okay, from n 0 infinity. This one at the same time equal 1 over n minus 1 n square. If you put n equal 2 here plus infinity, just we switching the terms here, index number from 0 to 2, then we switching this one to n minus 1 n square. It will be the same thing. Okay, this is our nice expression here. Now we are going to clean the board and then we'll rewrite this one. What's this one? We are not leaving this one like this. We should calculate it as a value. So let's see here. We'll use the decomposition form in order to make it very simple to solve it easily. So let's rewrite this one again. Our I integral is a sum of 1 over n minus 1 n square from 2 plus infinity equal. Now we don't need this one now. So if you take a look here, 1 over n minus 1 product n square equal 1 n minus 1 minus n plus 1 over n square. Okay, if you distribute this one, become n square minus n plus 1 product n minus 1 over n minus 1 n square equal plus 1 minus n square. Okay, n square minus square, so cancel out this one. So our expression become this one. So we are going to back to the original one. So we just verifying. Okay, so our expression, this one is this one. So this one we can simplify here, become n minus 1 minus 1 over n minus 1 over n square. Okay, let's rewrite this one in this form. So our I integral equal this one sum of 1 over n minus 1 minus 1 over n from n 0 infinity. Okay, minus n square 0 infinity. Okay, this one can calculate it, separate this one. So let's plug in 1 n minus 1 minus 1 over n equal 0 infinity. Let's plug a number, sorry, this one 2, because we already changed it. Okay, we already changed it to 2. Okay, this one, if you plug in number 2 here, become 1 over 2 minus 1 is 1, minus 1 over 2, plus 1 over 2, minus 1 over 3, minus 1 over 3, minus 1 over 4, and so on. Okay? And so on. So this one will cancel out with this one. So our sum it will be equal 1. Okay? This one. This one have also 1 over n squared equal to infinity equal yeah, we have this one 1 over n squared from n1 to infinity equal sum of 1n squared, yeah, 1 plus to infinity 1n squared. We skipping to the term 2 because the 1 equal 1, if you put the 1 inside 1n squared, it become 1 plus this one. So what is this? We already know this one is pi squared over 6. So we are looking for this one, right? So 1 n squared and infinity equal pi over 6 minus 1. Okay? We are going to plug here. So our I integral become, this is 1, calculate 1 minus this one. 1 minus pi over 6 minus 1 plus 1. Minus, right? Equal 2 minus over 6. Okay? Very good. The result of this value, the value of this integral is number 2 minus pi squared over 6. Thank you. If you like this video, just put a subscribe to see more math. Thank you. Bye.